Everybody. Today we're going to go ahead and start Unit 9, and we're going to kick it off with Lesson 9.1 over direct and inverse variation. So let's start with some bell ringers. Take about 3 or 4 minutes to try these on your own. Send a couple people up to the board to try these problems, and go ahead and pause the video. When you're done, you can resume the video and we will go over the problems together. All right. So what we should do is say that we're using the formula y equals kx. This is the direct variation formula we used back in Unit 2. And then we're going to say, okay, if x equals 2 and y equals 4, what is the value of y when x equals 5? So we start by plugging in these two values of 2 and 4 to the respective variables. So we're going to get 4 equals 2k. You can put k times 2, it's the same thing. We divide both sides by 2, and we get that k equals 2. So our formula is going to be y equals 2x. Now, we want to know what happens to y when x is 5. So we substitute that 5 in for x, and we get y equals 2 times 5. And we get that y equals 10. There's our answer to the first one. For the second one, we would say, okay, if x equals 1 and y equals 5, what happens to k then? So we have 5 equals, I'll do it the other way around this time, k times 1. Well, I could divide by 1, but really k times 1 is just k, so we know that k equals 5. So we're going to have y equals 5x. And then we're going to substitute in that value for x. And we get y equals 5 times 3, y equals 15. Take a second, make sure you got those copied down, see if your answers match, and when you're ready, you can go ahead and move on. So in this unit, we're going to talk about inverse variation. So an inverse variation can be modeled by any of the following equations. Notice that this middle one here is the most commonly used form of inverse variation. The most commonly used, but these other forms are also possibilities. If I multiplied both sides by x, I would get this form up here. I could solve this one for x by dividing by y on both sides, and that would give me this one. So all of these are just variations of the same formula. This middle one is just the one that is the most common and the one that we are going to use the most. So suppose that y and x vary inversely, and x equals 0.3, and when y equals 1.4. Write the function that models the inverse variation. So our formula for inverse variation we said that we're going to use is y equals k divided by x. Direct variation was k times x, inverse is divide them, k and x. Substituting these in, we get 1.4 equals k over 0.3. Multiply both sides by 0.3. Over here they cancel out, and we'll get k equals 0.42. So that's just our k value. We want to find the function that models it. So we have to write the function as y equals what our k value is over x. And that would be our final answer. All right. So try this one on your own. Compare your notes with each other, and then come back and see if your answer matches what we get here. So I'm going to substitute in my x and my y values, and we get 4 equals k divided by 7. I'm going to multiply both sides by 7. And I'll get 28 equals k. To write the function, I'm going to substitute in that value to our function y equals k over x. And I'm going to get y equals 28 divided by k, or x, excuse me. Final answer. So then there's some other types of variation, and one is for us to have joint variation. So it's possible that we have 3 or more variables, not just x and y, but now we're going to throw z and even some w in there. We could have more than 2 just variables being related. In this lesson, we're going to look at how a variable z can vary with different variables. So this table is very, very important to know. We need to be able to read a phrase like z varies jointly with x and y and know that that means we are multiplying them all together. If we have it varies jointly with x and y but inversely means now that we are dividing. So we start to see this pattern that jointly means we have multiple variables being multiplied together like k, x, y. Inversely means divide. If we have directly, that's like back in Unit 2 where we just have a k and an x together. So we're going to practice putting this all together and going from words to equation form. So the mass m of a moving object is related to its kinetic energy k and its velocity v by the formula m equals 2k divided by v squared. Describe the relationship as a combined variation. Slide. We did use this variable k, but the variable k just represents a constant. It represents a constant thing that wasn't changing, just like it did on, if I can get it to work, the previous slide. We talked about how, there we go, the value of k was this constant value of 28. So then when we go to, there we go. Sorry guys. So here, even though we have this k value here, it doesn't mean the k that was on the previous slide. It means that it is a variable now. And our constant value is this 2. And we never talked about the constant. So what we would say is m varies, and we always start with the variable that's isolated. So m varies, and since it's a constant times one variable, it's directly. Constant times one variable is directly. M varies directly with k, and divided means inversely with, and we're going to go ahead and put v squared. But that would be the relationship that's happening between m, k, and v squared. M varies directly with k and inversely with v squared. Oh, look at that. So, spoiler alert, here's the answer. The formula for the area of a trapezoid is A equals 1/2 h times b1 plus b2. So to describe the relationship, we would say that A is the variable that's isolated, so that's where we get what we start with. A varies. Next, I notice that I have a constant times 1, 2 things total being multiplied together. It varies jointly with the height, or with h, and with the sum, or b1 plus b2. I would take either of these answers. When we're given what h and b1 and b2, or when we know what they represent, it's better to write height and sum of bases. But it's okay also to write A varies jointly with h and the sum b1 plus b2. That would also be acceptable. All right, pretty short lesson today. You've got some homework problems, and make sure that you check those together and practice them in your notes together. If you have any questions, let me know. Thanks, guys.